Hello everyone, welcome to the next lecture on the PY question series of statistics. Today we will discuss about unbiased and consistent estimator PYQ. Myself Dr. Harish, you can simply follow my YouTube channel and find the playlist under this column, and you can see there is a playlist of the IIT Jam and you can find the various PY questions related to them. I must recommend it that you must watch the MLE PY question before watching this lecture. Apart from them, there are many other lectures available in this playlist. There is one more playlist named as the GATE statistics. If you are from the GATE examination, then you can find this for the various complete syllabus for this examination. So what is that? We will see. Firstly, I will tell you what is the various shortcut tricks and the concept behind the solving of PY questions, so that you can solve each question within the 10 to 15 second time periods. So if you want to prove any of the things to be the unbiased estimator, then you have to find the expected value of the t. If it is come to be gamma, whatever the estimator is there, then it is unbiased estimator, otherwise not. If E of t is not equal to gamma, then we call as this is the biased estimator, and the amount of the bias is calculated as expected value minus gamma. On the other hand, how you can prove it's a consistent estimator? If you prove that t of n, whatever the sequence are there, if you prove it converges to gamma in probability, or you can say if the weak of the large number hold for the sequence tn, then you can say tn is my consistent estimator. This is the first method you can prove by the prove the consistent estimator. Another way is, this is the sufficient condition for the t of n to be the consistent estimator. If you prove that E of Tn should be gamma as n approaches infinity and variance should be 0, then you can say Tn is the consistent estimator of gamma. Make sure in this case there is no need to apply E n approaches infinity. In this case there is no need. But whenever you are trying to apply for the consistent estimator, E of Tn must be approaches to the gamma as n approaches infinity. That's the most important thing. Second concept is, if you prove that the t of n is the consistent estimator of gamma and f is the any continuous function, then f of tn is the consistent estimator of f of gamma. Means if I say x bar is the consistent estimator of theta, and if I consider the function is x square, which is the continuous function, then you can say x bar square is the consistent estimator of theta square. If you consider function is say my x square plus 1, then you can say this plus this is the consistent estimator of this. However, this result is not always true for the unbiased estimator. Means if A is the unbiased estimator of B, that means expected value of A is my B, then f of A is not in general unbiased estimator of f of B. So let's start with this simple shortcut tricks, how you can solve that. You have to read the statement very carefully. x1 and x2 are the two independent having the same mean. So expected value of x1, which is same as expected value of x2, and it is given as a theta. What is the meaning of this? Expected value of x1 minus this is the mean. So basically this is the variance of x1. It is given as a 1. If you look about this is the x2. Again, this is the theta is the mean of the x2. So I can say the variance of x2 is my 2. Consider the estimator t of alpha is the linear combination of this, for which the variance of t alpha is a minimum. So can you find the variance of this? So I can simply say it's a alpha square variance of x1 plus 1 minus alpha square variance of x2. I can substitute the value of the variance plus 2 times 1 minus alpha square. Now how you can check about the variance? I can check about the option. If alpha is my 2 by 3, so if I substitute here, it is 4 over 9 plus 2 over 9, so it's a 6 over 9, that's a 2 over 3. If I look about the second option, it's a 1 over 2, it's a 1 over 4 plus 2 over 4, it's my 3 over 4. If you look about the third option, it's a 1 over 4 plus it's a 3 over 4, 9, 18 over 16, that's my 19 over 16. And if you look about the last option, it's a 9 over 16 plus it's a 1 over 4, so it's a 2 over 16, it's 11 over 16. Now look at that, which one is the minimum. So this value is my 0.75, this value is my 0.66, so definitely it is not. This number is 1 point something, it is not, and this number is greater than of 0.66, so this option is also cancelled. A is my right answer of this problem. There is one more method how you can find the minimum of this. If you take the derivative of this with respect to alpha, then you can put them as a 0. Fine. So you can find the value of alpha from here. So plus 2 alpha is 0. It's a 2 alpha. It's a 4 times. So it's a 4 plus 4. So it's a 6 alpha is equal to 4. Alpha is my 2 over 3. So again, either you can use this derivative or otherwise you can substitute these options. If xi's are my Bernoulli distribution, then capital T is my, here is the biased. Now look at that. We all know if xi's follows my Bernoulli, then some of them will follows my binomial distribution with the parameter n and p. Then your target is to find the bias. So bias means expected value of t minus of p. So I can find the expected value of this. So 2 n plus root n is a common. What is the expected value of root n is my here, plus what is the expected value of this? It follows my binomial. So what is the mean of the binomial? Np. So it's a 2np minus p. Now I can take the LCM. So you can see 2 and p will be cancelled out. So it is a root n plus minus 2 root n p divided by 2 times n plus root n. I can divide it by root n on the both side. The numerator part will be 1 minus 2p. Denominator part will be root n plus 1. So you can see I can take 1 by root n plus 1 is a common. So it is a half minus p is the right answer of this problem. Xi's are follows my Bernoulli distribution, then which of the following estimators are there? So again, sum of xi's will follows my binomial distribution with the parameter n and p is my here. Then consistent or unbiased. I can found the E of t. Again, n plus root n is my common. So what is the expected value of this is? It's a n theta plus root n over 2. So clearly say this value is not theta. Fine. So what does it mean? T is my not unbiased. Fine. So you can see about the option. He said this is the unbiased. So this is cancelled. This is the unbiased. This is cancelled. Now how you can check about the consistent? So I can take as n approaches infinity of this. So what is my E of t? So if you take n approaches infinity, I can firstly write it like here, this plus root n over 2 n plus root n. So whenever n approaches infinity, this value will goes to the 0, this value will goes to the 1. So that means it's a theta. So first property satisfied. Now I can find the variance of t. If it goes to the 0, then we can say this t is the consistent estimator. So how you can find the variance? This is whole square. The variance of this value is a 0 because the constant. What is the variance of this? It's a npq, np and here. So clearly say degree is my 2 and hour is 1, so it will goes to the 0. So therefore t is my consistent estimator. So t is the consistent but not unbiased. The right answer of this is my correct. Xi's are my normal distributions. The value of k for which this, if I call this is my capital T, is the unbiased estimator. So this value is given to you. Fine. Now it's very simple. If I calculate the expected value, k will be outside. Summation of I varies from 1 is outside. So expected value of mod xi. Fine. Now remember, whenever x follows my normal distribution with the mean 0, variance sigma square, always remember expected value of the mod x is 2 over pi root into sigma. So if I substitute here, what is the answer of this? Is a 3 times I varies from 1 is a root 2 over pi. What is the sigma? Is standard deviation. So what is the standard deviation of this? Is theta. So it will be cancelled out. So it is my 3 times of this. Fine. So what is my k? K is my root pi over 3 divided by root 2. So root pi in the numerator. So this is cancelled, this is cancelled, this is cancelled. Now you can see I can return this number is pi over root 18. So C is my correct answer. Okay, which of the following is the unbiased estimator? Okay, always remember, whenever you have a normal distribution of A comma B, always try to make this to be a 0 comma something. Try to make them. Now you can see this is a 5. So I can clearly say if x follows uniform distribution of 5 plus this, can you make them? Yes, you can easily make. If I subtract them 5, then it follows my of this. Clear? Now then it will be the easy. So if I call y is my x minus 5, so what does it mean? Y follows uniform distribution of this one. Clear? Then I can find, because I need a theta square, so theta square is obtained from the variance of this. So variance is theta square over 12. Fine. Now if I look about this, this is x minus 5. So this is not the x minus 5, this is not the x minus 5. It can be written like here. Okay, so I can solve like this way. So it's a y square. I can start from the y square, expected value of y square. Fine. How can I find the expected value of the y square? From this variance of y plus expected value of y whole square. So what is that? This is theta square upon 12 plus mean is theta upon 2. I hope you all remember, whenever your x follows the normal distribution of A comma B, then expected value will be A plus B over 2. Variance of the x will be B minus A whole square over 12. So what is that? If I take the LCM, is a theta square over 4. 12 is the LCM, 3 plus 1. So 4 over 12. 4 over 12 is my theta square over 3. So expected value of the y square. So what does it mean? Expected value of the 3y square is theta square. So that means this is my unbiased estimator. So 3y square, this is my y. So 3y square is the right answer of the problem. Okay, what is given to you? Xi follows normal distribution with the mu comma 1. Fine. X bar. What is the x bar is? We all know x bar will follows the normal distribution with the mean is mu. Variance is sigma square over n. So it's again a normal distribution. Sigma square is my 1 over n. Then capital T is unbiased or his. Can you find the expected value of T? Half is outside. What is the expected value of the x bar? Is a mu. Expected value of the xn plus 1, mu. So this is my mu. So what does it mean? T is my unbiased estimator. So T is biased, cancel out. Now is it consistent? I can found the variance. If it is goes to the 0, then we can say yes, this is the consistent. So what is the variance is? 1 over 4 is outside plus variance of xn, it's my x bar. Variance of the x bar is 1 over n plus variance of xn plus 1 is 1. Does it goes to the 0 as n approaches infinity? No, because whenever n approaches infinity, its value is my 1 over 4. So it means T is not consistent. So he said consistent, cancel out. Inconsistent is the right answer of this problem. Okay, so xi is okay. If x follows my uniform distribution of this, fine. Now xn is the consistent estimator of theta. Okay, firstly I will give you the tips. Whenever x follows my uniform distribution of A comma B, fine, then the x1, that is the ordered statistics, minimum of the ordered statistics, is the consistent estimator of this A. Xn is the consistent estimator of upper limit B. So in this case, upper limit is my theta, so xn is the consistent estimator of theta. So xn means maximum of this, so it means this is my consistent estimator of theta. So T2 is the consistent estimator of theta, that's fine. Can you say T1 also? Okay, now we can see what is a T1. Moreover, there is one more tips that come directly in my mind is xn is sufficient estimator of theta as well. Although we will cover the sufficient estimate in our next lecture, but that the tips come in my mind, so I can write here for you. Okay, so T2 is my consistent estimator of theta. So what is a MLE? Okay, so how you can find the MLE? So it's a uniform distribution, so I can return this is my here. Fine, so it means that theta should be greater than or equal to xn. So theta belongs to my xn and the upper limit is my infinity. So what is the function is? Function is 1 over theta. So clearly say how you can maximize this. Maximize only when this will be minimum. So what is the minimum value of this? This is my minimum value. So this is my MLE. So xn, that is my T2 is the MLE. So that's a fine statement. Method of the movement. So how you can find the method of movement? That's a mean. So this mean is the mean of the uniform distribution is here. This is my x bar. So what is my theta? This is my 2 times x bar, which is again a 2 times x bar. So yes, this is my correct statement, but we need a not a correct statement. Fine. Now T2 is the consistent estimator, that I already proved that. Now is that T1 is the consistent estimator? We will check about here. Fine. So what is the expected value of the T1? So 2 over n is outside. What is the expected value of the xi's? Theta upon 2. So clearly say it's a n times. So n will be cancelled out, say theta. First property satisfied. What is the variance of T1? So it's a 4 over n square summation variance of the xi's, theta square over 12. So it will be n theta square upon n square into 3. So clearly say it goes to the 0 as n approaches infinity. So yes, T1 is consistent estimator. So yes, this is also my correct statement. T1 is my unbiased estimator. So T1 is my unbiased estimator, already proved. So T2, can you say that T2 is my unbiased estimator? Okay, so what is the distribution of the T2? So T2 distribution always follows my beta distribution of n comma 1. Okay, I can again give you the tips. X1, whenever x follows the normal distribution, x1 will follows the beta distribution of 1 comma n. X2 will follows the beta distribution of n comma 1. Fine. So in this case, this is my T2, this is my xn. So then what is the expected value of this x1? What is the expected value of T2? So what is the mean of the normal beta distribution is n over n plus 1, because there is a parameter theta, so I can return this is into theta. So clearly say E of T2 is not equal to theta. So it means T2 is not unbiased, but he said unbiased, so yes, this is the correct statement. T2 is the sufficient estimator. I already give the tips that for the uniform distribution, the xn is the, so this is also the correct statement. So the only right answer is C is my here. Remember, I have used here if x follows my beta distribution of a comma b, then the mean of this is my a over a plus b. Okay, look at this another one. You need to find the consistent estimator. So do you identify which distribution is here? Is it a gamma distribution? No. Why? Because remember, this is fine for the gamma distribution, but for the gamma distribution this value should be only x, so it is not a gamma distribution. So how you can find the consistent estimator? I will tell you the two different methods. The first method is, if you look about this, if I called x4 is my y, then 4x cube dx is my dy. So that means here, fine. So what does it mean? This is basically converted into, if I consider x4 over theta is say my y, fine, then this is my derivative, so this is my basically here. So that means it's the exponential distribution. Y follows the exponential distribution, means x raised to power 4 follows the exponential distribution with the mean 1, fine. Now if I consider the x4, then it considers the mean theta, fine. Now what is that? Now for the consistent estimator, you are using the weak law of the large number. So since xi's are my IID, so it means xi4s are also IIDs. So once you are IID, so it means this value will converges to the expected value of xi4. So what is that? x4 will converge is the exponential distribution of with the parameter this, so it will be my theta. So what does that mean? That means this is my consistent estimator, and the rest of part is not belongs to the x raised to power 4, so that's why this will be cancelled. This is the first method. There is one more method. So whenever you are talking about the consistent estimator, find the MLE, fine. So how you define the MLE? As I told you in my last lecture, so you can consider only those functions which are dependent on the theta. So it is 1 over theta and it is here, fine. So define the L, so it is product and it is my summation of x4 by theta. Take the logarithm, it is my minus n log theta minus x raised to power 4 over this. Now find the derivative, and here, so minus n over plus summation x4 over theta square is my 0. So what is my theta? It is 1 over n summation x4. So whatever this is my MLE of theta. So whatever the MLE of theta, it is always be the consistent estimator. So from here you can see A is my correct answer. Okay, xi's are follows my normal distributions, then sum of them. Can you find the distribution of the T1? If xi's follows the normal distribution, then Ti's also follows the normal distribution. What is the mean is? N into theta. What is the variance of xi is? Variance of xi is my this. If I add them, it is n theta square, fine. Then it's an unbiased T1 square. So can you find the expected value of T1 square? This is from the variance of T1 plus expected value of T1 whole square. So what is the variance of T1? N plus is a n square theta square. Now I need a divided by n square. So if I divide it by n square, so what will happen? It is a theta square over n plus, so clearly say this is not is equal to theta square, fine. But as n approaches infinity, that can be. But for the unbiased estimator, we need without n approaches infinity. So it means T1 square over n square is not unbiased. This is cancelled out. T1 square over n square is a consistent. So clearly say this approaches. Now for the as n approaches infinity, this belongs to this, fine. But I can use, I think I can use the weak of the large number. That quite easy for us, fine. Now how you can solve that? Okay, firstly I can check about this. How you can say, can you find the variance of T1 square? If I found the variance, it will be my here minus this value, fine. So how you can find the expected value of this? How you can see that? For that I need to use 1 by theta sigma square. Okay, but I can use the weak law of the large number concept. That quite easy. So T1 square over n square. Okay, if I prove what is the T1 is a sum, fine. This divided by n. So by the weak law of the large number, this will converges to the expected value of the xi's. Fine. So what is the expected value of xi is theta. That means T1 over n will converges to the theta is the consistent estimator. Now you can see that if I consider function is x square, which is a continuous function, so T1 square over n square is also the consistent estimator of theta square. So yes, this is the right answer. Now T2 upon 2n, so I can find the distribution of the T2. So let me clear this screen. So what is the T2 is my here. Fine. So can you find the distribution of the T2? So T2, so expected value of the T2 will be, so it's a n times expected value of xi square. Fine. So what is the expected value of xi square? I can obtain from variance. So it's a theta square plus whole square. So it will be my 2n theta square. So I need a T2 divided by 2n. So what is the expected value of this? It is my, so what does it mean? This is my unbiased estimator. Now they are talking about the consistent estimator. So again, how you can do that? I need to find the, either I can use the variance, okay, or you can use weak law of the large number again. Fine. So how you can prove that it's a weak law of the large number? T2. So clearly say 1 over this number by the weak law of the large number, because xi's are my IID, it converges to expected value of xi square. Fine. What is the expected value of the xi square? Variance is my this plus theta square. This is the expected value of this, or I can say expected value of this divided by 2n. If divided by 2, it is my theta square. What is that? This is my T2 divided by 2n converges to the theta square in probability. That means weak law of the large number hold. We can say yes, this is the consistent estimator. So T2 divided by 2n is the consistent estimator of theta square, is the correct answer. Okay, consider a simple linear regression model with the n observations. Beta i's are the unknowns. Random error for the real number ai's. This is the unbiased estimator of beta. So beta 1 will be expected value of summation ai's y. This is given to you. Then which of the following cases hold? I can substitute the value of yi's and I can open this summation. So it's a ai beta naught plus beta 1 ai xi. Error has the 0, so I can written as a 0. Now if I open this bracket, so it will be beta naught is my constant, is outside, summation of expected ai's, expected value of this, so it will be n times of this, plus beta 1 is outside, expected values of this, so expected values of this number. Fine. Up to here is okay. Now how you can think about this? I can, because this is with respect to I, so this is also I. Now it's a beta 1, so I can equate the coefficients. Fine. There is no beta involved, so it means n beta naught summation ai's will be 0, and from here expected values of this will be 1, so that means summation of xi's ai should be 1, and from here n can never be 0. Beta naught is the unknown parameter which is a non-zero, so that means summation of ai should be 0, and these conditions, summation of ai 0, sum 1, summation is 1, this one, this is a 0, both are 0, not possible. Only case is B is the right answer. Okay, look at this another one. Xi's are my random distribution with here. Okay, it is look like say exponential distribution, but for the exponential distribution we need this value, but here is a x minus, so I can consider y is x minus theta. Then what does it means? It means y follows my exponential distribution with the parameter 4. Is it fine? So now T1 of this, okay, remember tips. If x follows my exponential distribution with the parameter lambda, fine, then x1, that is the minimum of this, is the consistent estimator of this lambda. Fine, x1 is the consistent estimator of this lambda. So what is that x1 is? That is a minimum. So from this case, what can you say that? That means y is my here, so it means y of 1 is the consistent. Okay, I can also tell you one more tips before I solve this. If x follows my exponential distribution with the parameter this, then x1 is also follows the exponential distribution with the parameter n comma lambda. So I can found the y1. Y1 also follows the exponential distribution. What is the n is? N is my n. It is my 4n. Fine. So what does it mean? Yn is my here. So it means x1 will follows theta plus exponential distribution of the 4n. Then this one is my tn. So this is basically a tn. Fine. So now I can find the expected value to check whether it's a biased or unbiased. What is the expected value of this? This is my constant number. What is the mean of this is 1 over 4n. So clearly say this is not equal to theta. So tn is not unbiased. So tn is biased. Tn is unbiased, cancel out. Fine. Now look at the second options. Now you have to check about the consistent estimator. So clearly say as n approaches infinity, E of Tn will be my theta. So first property satisfied. Then we have to find the variance of Tn. That means variance of xn, or I can say this is the xn. Okay, this is my constant value. So variance of the constant is 0. What is the variance of the exponential parameter? 1 over lambda square. So clearly say it will goes to the 0 as n approaches infinity. So yes, this is my consistent estimator. So Tn is the biased, Tn is the consistent estimator is my right option of the problem. Okay, which of the following, again xi's are the normal distribution, which of the following is my consistent estimator of theta? Okay, so what is the meaning of that? Xi's are my normal distribution of this. Fine. So it means first of all this one, this is the consistent estimator. By using the weak law of the large number, it converges to the expected value of the this by using the weak law of the large number. But what is the expected value of this? It's a 2 theta, but we need a theta, so this option is cancelled out. This value will converge to the expected value of xi square, because this is a 5 also, divided by 5. What is the expected value of xi square? I can see from here, theta square plus 4 times theta square. So it is a 5 theta square over 5. So that means a theta square, but we need a theta. This is also cancelled out. If I look about this one, I can simply find this firstly. Fine. And this root I can use as a function of continuous function from here. Fine. So this value will be convergence to the 5 times expected value of xi square. What is the 5 times of the expected value? Is at 25. 25 theta square. Fine. Now if I take the square root of this, it will be my 5 times theta, but again we need a theta. This option is cancelled. But if we look about this option, this will be convergent to the half expected value of xi square divided by 5. So it's a 5 theta square upon theta square is theta square, and you can see this goes to the theta. So yes, this is the right answer. Look at this another one. x1, x2 and x3 will follows my exponential distribution with the parameter here. Fine. Which of the following estimate has the smallest variance? Okay, whenever you are talking about the smallest variance, which thing come in your mind? Minimum variance, unbiased, estimator. Fine. And always remember, whenever you have exponential distribution of the parameter theta, fine, then x bar is my sufficient estimator, x bar is my unbiased estimator, x bar is my minimum variance unbiased estimator. So you have the three samples. So what is the unbiased estimator of this? That is here, divided by 3. Then which of the following has the smallest variance? I can find this variance of here. So what is the variance of this? 1 over 9 outside. Variance of x1 is, the parameter is this, so variance is theta square. Second is also theta square. Third is also theta square. So right answer is 1 over 3 theta square. So which of the following has the smallest variance? The one way is this. Otherwise you can find the variance of this. It is 1 over 25. Variance of x1 is, variance of xi is theta square. So it is my theta square plus 9 plus theta square. So it is my 9, 10, 11 by 25. So it is 11 over 25 theta square. This value will be 1 over 9. So 1 over 3 theta square. Okay, because I got as a x bar is a minimum variance, so this is the right answer. This is the second way you can find the variance for each category. It's a 1 over 16, it's a theta square plus 4 times of this, so it's a 6 over 16, and this is 9, 10, 14 over 36 theta square. So clearly say 1 over 3 is the minimum among them. Look at this next one. Xi's are my here. It follows my Bernoulli distribution with the parameter theta. Which of the following is the unbiased estimator? Can you find the mean of the Xi's from here? What is the mean of the Bernoulli distribution? Theta. So I can check about the option. What is the mean of the first part? Okay, I can find the mean of options, and if it is a theta, then this is the right answer. Half is outside. Theta plus theta is a theta. Yes, this is unbiased. Second option, half is outside. Expected value of the xi square. So how you can find the expected value of xi square? I can use the variance of x1 plus expected value of xi whole square. So what is the variance of Bernoulli distribution? Theta into 1 minus theta. So it's a theta minus theta square plus, so this is also theta, plus x2. The mean of x2 is my here, which is also same one. Look at the third option. Half is again outside. Expected value of the xi square is this plus this, which is also the same, is the right answer. Look at the fourth option. Half is outside. This is theta plus theta minus theta, which is equal to theta upon 2, not equal to theta. So this option is cancelled. A, B and C are the right answers. Okay, look at this one. X follows exponential distribution with the parameter here. Theta is my unbiased estimator of theta. So what is the exponential distribution? As I told you, what is my theta? Theta is my x bar. For the exponential distribution, x bar is the unbiased estimator. Which of the following cannot be attained? The variance of delta means variance of x bar. 3 samples. So variance of this. So it is 1 over 9 is outside. If variance of the x will be theta square, because you all know whenever exponential distribution is 1 over lambda square, it is lambda is 1 over here. So theta square and here. So what is the variance at 0.1, so it is a 3, 1 over 3, so cannot be attained. So variance is a minimum variance. Fine. So once it has a minimum variance, so which is 0.33, which are the following can, because this is the minimum variance, so the minimum variance means at least should be 0.33, which are the following cannot be satisfied. So these three are not satisfied for these cases. So the right answer is, this is the minimum variance you are needed as a 0.3. So A, B and C are the right answer of this problem. Look at this next one. Okay, so xi follows my uniform distribution, xn are here. So what I gave you the tips earlier, if x follows my uniform distribution of this, then xn is the consistent estimator of this upper limit and x1 is the consistent estimator of the lower limit. But here the lower limit is 0, so we can't say x1 is. So xn is the consistent estimator of theta. Now that's fine. So what you obtained, xn is the consistent estimator of theta. Now your target is to find the cube, so I can choose the function as x cube. Fine. So this is the consistent estimator. Now we can see, is it consistent estimator? If you choose the function as 8x cube, then it will be the 8 theta cube, but we need only as a theta cube. This is the cancel out. What about this? Now I can apply the weak law of the large number. This will be convergence to the improbability of cube. It's a 2 times expected value of xi, because n is average. So what is the answer of this? What is the expected value of this? So 2 times, what is the expected value? Theta upon 2. So you can see that it is again theta cube. So yes, this is the right answer. For that, it is convergent to the consistent estimator. So what is that? It approaches toward n over n plus 1. Expected value of this will be theta cube, or you can choose as a function of nx cube plus 1 over n plus 1. You can see this is the continuous function. Fine. So if instead of the x cube it's a continuous function, so that's over. If xn is the consistent estimator of theta, then n, this is the consistent estimator. No, you can't do that because it will be here. So I can check about by definition. If I found the expected value of this, it is n over n plus 1 is outside. Expected value of the x cube is here, so which is not the consistent estimate. So just wait, this is the consistent estimator. So for this is the they are asked for the consistent, not for the unbiased. This is not the unbiased, but clearly say this will belong to the theta cube as n approaches infinity. So yes, this is the consistent also. I think about it's a unbiased. It is not an unbiased, but it's a consistent estimate. Moreover, another way you can think about that, I can return this number is n plus 1 x n cube plus 1 over n plus 1. So clearly say what is to happen as n approaches infinity. This will goes to the 0. This value will goes to the 1. So it is my xn cube, and xn cube will converges to the theta cube by using the function here. So yes, B, C, D are all my correct options of this problem. Okay, look at this another one. X follows my uniform distribution with theta and theta plus 1. Then which of the following is consistent? So what is my shortcut tips for you? X1 is the consistent estimator of the lower limit, and xn is the consistent estimator for the upper limit. So what is that? This is my x1. So that means V is the consistent estimator of theta. U is the because U is my here maximum of this is the consistent estimator of the upper limit. Fine. Now you can see U is the consistent estimate of theta, wrong. V is the consistent estimate of theta, correct. Now what is that? 2u minus v minus of 2 this is the consistent estimator of, I can substitute this value, 2 times this minus of theta minus of 2. What is happen? 2 theta plus 2 will be cancelled out. So it is my theta. So this is the consistent estimator of theta. Again, look at the last option, 2 times v. V is my theta, u is my theta plus 1 and of plus 1. So this will be 2 theta will be here, minus 1 will be cancelled. So this is the consistent estimator of theta. Always remember my this shortcut tips for you that will help you whenever there is exponential or there's a uniform distribution appears. Okay, consider the random sample of this. TIs are here, which of the following is the unbiased estimator. Means your target is to find expected value of t and it should be comes to be mu. Sorry, expected value of options. You have to find the expected value of the options. Okay, so if I look about the expected value of the t, because they are the random samples, so it is my n times expected value of this xi's. Fine. Now how you can find that? Can you identify which one is which distribution it follows? This will follows normal distribution. So I can return this f is half, I can taken as a constant, 1 by root pi of this. The first one is follows the normal distribution with the mean 2 mu. Fine. Variance is my 1 plus again this follows the normal distribution when I taken 1 by root 2 pi inside with the mean is 4 mu. Okay, and the variance is again 1. So then what is the expected value of this random variable? Half. Expected value is my 2 mu plus 4 mu. So it is my 6 over 2 is a 3 mu. So the right answer is 3n mu. So what is the meaning of that? I can return expected value of 3 over t over 3n, which is comes to be mu. So t over 3n is my is the unbiased estimator of mu. Okay, again it's a uniform distribution. So then t of n, that is a minimum. So what is my shortcut tips for you? X1 is the consistent estimator of the lower limit. So x1, that is the minimum of this. That means t of n is the consistent estimator of theta. Fine. Then this is the correct option. T of n minus 1, it is not. Why? Because you can see t of n minus 1 is the consistent estimator of theta minus 1. But we need only as a theta. This one, t of n plus 1 over n is the consistent estimator of theta plus 1 over n, and it goes to the theta as n approaches infinity, although this value still goes to the theta minus 1 as n approaches infinity. So this value is my theta. So yes, this is also the consistent estimator. This value tn minus 1 over n square, it goes to theta minus 1 over n square, and again it goes to as n approaches infinity is theta minus 1, but we need only as a theta. This is the wrong answer. A and C are my correct options. Okay, which of the following is my consistent, biased, unbiased? Okay, xi minus xj. If x follows my normal distribution, fine, then can you define xi minus xj distribution? It follows my normal distribution with the mean is mu minus mu 0 and the variance is 2 sigma square. Fine. Now which thing come in your mind whenever you have written the normal distribution and the square? Always remember the one tips for you again. Whenever x follows my normal distribution of this, then x minus mu divided by sigma, this will follows my, yes, it follows my chi-square distribution with the degree of freedom 1. Now I can see here, if I look about this value xi minus xj whole square, because mean is my 0 divided by sigma square, so variance is my 2 sigma square, it follows my chi-square distribution of 1. Fine. Now for this double summation, so clearly say if I, in this case I and j, if I take I1 j1, it will be my 0. Fine. So I can simply take I is not equal to j. So it means if I divide it by 2 sigma square multiply by 2 sigma square, there is no worry about that, then this double summation of this value is follows my chi-square distribution. The degree of freedom is the total number of elements are n square, and I subtract all those elements in which I is not equal to j, that means minus n. This is my degree of freedom. So that w now comes out to be my, so if I call this is my say y, so then w will be 2 will be cancelled out, sigma square over n square of y. Then I can check about the mean of this. It is sigma square over n square outside. So what is the tips again? If y follows my chi-square distribution of n, then expected value of the chi-square is n, variance of the chi-square is my 2n. So I can substitute here what is the mean of the y, degree of freedom, n square minus n. So clearly say which is not equal to sigma square. So this means w is the biased estimator. So unbiased cancel, unbiased cancel. Now is it a consistent estimator? I can take as n approaches infinity, so it will be 1 minus 1 over n. So clearly say it goes to the sigma square as n approaches infinity. I can found the variance also. If variance will goes to the 0, then we can say w is the consistent estimator of sigma square. So what is the variance is? Sigma 4 over n4 is outside. Variance of y will be twice of n square minus n. So clearly say it has the degree 4, it has the degree 2, it goes to the 0 as n approaches infinity. So yes, w is my consistent estimator. So inconsistent cancel, consistent is my right answer. Okay, look at this one. Again it is similar of this. It follows the exponential distribution, but if I simply take y is my x minus 2 mu, then your f will be half e raised to power half of x, half of y. So it means y follows my exponential distribution with the parameter half. So I can say x follows, I can find the value of the x is a 2 mu plus exponential distribution of half. Then t1 and t2 are defined to be this, consistent and inconsistent. So I can found, firstly I can found the x bar. X bar means e of x. So this will be my 2 nu, is a constant value. What is the expected value of this is my 2. So if I substitute expected value of t1, t1 will be half is outside. Expected value of the x will be my 2 nu, so it will be 2 will be cancelled out. So it is my mu. I can found the variance of t1. So it is 4 is outside. This is my 0. So variance of x bar. So what is the variance of the x bar? We all know x bar will follows the normal distribution with the mean mu and sigma square over n. What is the mean of this x bar? Mean of this is 2 mu plus 2. What is the variance of this? Can you find the variance of x? This is the constant value, is a 0. Variance of this is my 4. So it is 4 over n. So it is 4 over 4n. It goes to the 0. So yes, t1 is my consistent estimator. So t1 is the consistent. Neither t1 is consistent. t1 is not consistent, cancel. Now look at the second option. What is given to you? Okay, so this is my x. So x1, fine. So from here, as I told you in my previous tips, y1 is again follows, or you can directly write as what is the tips as I given you earlier. If x follows the exponential distribution with the parameter lambda, then the minimum of them will also follows the exponential distribution with the parameter n comma lambda. So I can start from here. X1, which is a simple 2 mu plus exponential distribution of the parameter n by 2. So this is my x1. Then I can find the mean of this. expected value of T2. Fine. Then what is the expected value of the T2? It's a constant value plus what is the mean of this value is 2 over n. So clearly say this will belongs to the 2 mu as n approaches. Okay, I can substitute here also. So what is the expected value of, this is my x1. So expected value of the T2 will be 2n is outside, n times of this. So 2n mu plus 2 minus of 2. So 2n is cancelled out, it's a mu. So T2 is my unbiased estimator. Now for finding this variance of T2 will be 1 over 4n square is outside. It is my n square variance of x1. So can you find the variance of x1 from here? Variance of that 2 nu is a 0. It is 1 over 4 is a 0. What is the variance of the exponential distribution is 1 over lambda square, and clearly say it goes to the 0. So yes, T2, both T1 and T2 are my consistent estimate. Okay, look at this another one. X follows my normal distribution of this. For some real C, Y is the unbiased estimator of sigma. This is given to you. Find the value of C. So I can substitute the value. C over 10 is outside. Summation I varies from 1 to 10. Expected value of mod xi. So I think I already gave the tips for you. If x follows my normal distribution with a mean 0, variance sigma square, then expected value of the mod x will be 2 over pi into sigma. So I can substitute here to C over 10, it's a 2 over pi. What is the variance? What is the standard deviation is? Sigma. Fine, it is from I1 to 10. So sigma will be cancelled out. It will be my C over 10 into 10 times of this, which is 1. So what is my C? C is my pi over 2. So you can use the calculator and get your answers at here. So this is the way you can solve all those unbiased and the consistent estimator question in a very simple manner. We will see the next lecture on the unbiased minimum variance examples. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.